Lesson 2, Scientific Notation and Small Numbers. Our objectives for this lesson are, first, to write a decimal standard number in proper scientific notation, and second, to be able to write scientific notation numbers that have negative exponents back in standard notation. Let's start by taking a look at decimal powers of 10. As you can see, we have our decimals, 0.1, 0.01, 0.001, and so on. Recall that a number like 0.1, which is 1/10, can also be written as a fraction. Note also that a number 10 is 10 to the first power. 10 to the negative first power is 1/10. We take a look at the second one, 0.01, that's 1/100th. 100 is 10 to the second power. 1/100th is 10 to the negative second power. We're going to use these in order to write our numbers now in scientific notation that are originally written as small decimals. Let's take a look at some examples. We are first going to take a number in standard notation, 0.0005, and write it in scientific notation. Just like writing a number that is large in scientific notation, the first thing we do is we write the number and move the decimal after the first number. Just like with large numbers, that number should always be bigger than 1 and less than 10. In this case, when we move the decimal after the first number, we get 5. Next, we put in our times 10. Then we count how many places we had to move the decimal. In this case, we have to move the decimal 4 places to the right. So our exponent is a 4, but it's negative because we moved the decimal to the right. Now let's take a number in scientific notation and write it in standard notation. Our number is 4.5 times 10 to the negative 9th. So the first thing we do is we put down our number, 4.5. Next, we need to move the decimal. The negative 9 tells us that we have to move the decimal 9 places to the left. So we end up with a decimal point, 8 zeros, and then 4, 5. This could seem a little confusing at first, but there is a hint that we can use, especially when writing the number in standard notation. When putting a number with a negative exponent back into standard notation, there will always be one less zero between the decimal point and the first number and the positive of that exponent. If we look back at the previous example, we had 4.5 times 10 to the negative 9th. The positive of our exponent is a positive 9. 1 less than 9 is 8, and we ended up with 8 zeros between the decimal point and the 4. Now that we've done these examples, you should be able to do problem set 2.